Hello, Ian here from Crack Maths, and welcome to part 10 of answering every question in the book, where I'm completing every question in my Functional Skills Level 2 Maths book, which has broken the entire Functional Skills curriculum down into 70 topics and has multiple questions on each one. Let's get started. Let's get started with this question. I'm going to begin with topic 51. Oh, this says topic 50. We've actually covered topic 50, so we are ahead of the game. So topic 51, here we go. It's all about calculating the surface area of a cuboid. Just as a little point of reference, if you see these little things here, these QR codes, if you can scan them if you want to, these link directly to tutorials on how to do the topic that we are doing, if you feel like you need a little bit more help and guidance on that. Okay, so let's begin. Right, question 1 says, a cuboid has length 6 centimeters, width 4 centimeters, and a height of 5 centimeters. What is the total surface area in centimeters squared? So cuboids have 6 faces, which have got which all involve the multiples of these rectangles. So we've got the top and the bottom rectangle, the front and the back rectangle, and the two sides rectangles. So if we've got here length 6 and width 4, we'd then have another rectangle which has the length and the height, which is 5, and then we'd have one last rectangle which has the width and the height. Okay, so in that case that would be 4 and 5. So basically it's just the 3 combinations of these numbers. To find the area of a rectangle, you just do the 2 dimensions multiplied together, whatever they may be. So in this case we're going to have 24, and this one's going to be 30, and this one will be, the width was 4, so this one will be 20. Okay, and then what we can do is we can add these together. Okay, so this is going to be 50, 74. Okay, and then because each rectangle appears twice, we can then multiply this answer by 2. Okay, so 74 times 2 equals 148 centimeters squared. So the surface area of the cuboid will be 148 centimeters squared. Okay, cool. Right, let's continue with question 2. So here we go. The dimensions of the cuboid are 8 by 6 by 10. So that means we've got an 8 by 6 face, we've got a 8 by 10 face, and we've got a 6 by 10 face. Okay, so here we go. This is going to be 48, add 80, add 60. Okay, we can add these together. So 60 and 40 is 108. Add the 80 equals 188. Okay, and then there's 2 of those, so we need to double this number. So I'm just going to get the calculator out for that. So 188 times 2 equals 376. And this is meters squared this time. And it's the surface area because we found out the area of each rectangle. Okay, so here we go. If a cuboid has length 12 inches, width 4 inches, and height 7 inches, what is its total surface area in square inches? So what we're going to have here is we're going to have 12 by 4. Okay, we're going to have 12 by 7, and then we're going to have 4 by 7. Okay, so this is 48, this is 84, and this is 28. So we can then add these together. So I'm just going to be lazy now. So 48, add 84, add 28. Here we go. So that equals 160. And remember, each face is repeated, like on the back and the front, on the top and the bottom, and the side and the side. So this is going to be 160 times 2. So if we times this by 2, we get 320. So 160 times 2 equals 320. And that'll be square inches this time. Square inches. Okay. Right, question 4. Find the total surface area of a cuboid with length 10 centimeters, width 12 centimeters, and height 8 centimeters. Give your answer in square centimeters. Okay, so let's sort that out. So we've got 10 by 12, 10 by 8, and then we've got 12 by 8. So 10 by 12 is 120, 8 by 10 is 80, and 8 by 12 is 96. And then if we add these together, this is a nice, because 120 and 80 pair to 200. So these add together to give 296, and then we can multiply that by 2. So 296 times 2 equals 592. So 296 times 2 equals 592, and that is square centimeters. So I'm just going to actually just write centimeters squared. So here we go. Right, perfect. Okay. What's that? Oh, sorry. Right. Okay. Question 5. The dimensions of a cuboid are 5 by 3 by 2. Calculate the total surface area in square meters. So what we've got is we've got the 5 by 3, we've got the 3 by 5, we've got the 3 by 2, and then we've got the 5 by 2. Okay, so here we go. Got 15, add 6, add 10, and then if we add all of these together, so 15 add 10 is 25, 25 add 6 equals 31, so that's 31, and then if we times that by 2, that would be 62 centimeters squared. Okay, question 6. I think what I might do is I might actually just complete the set of 10, and then we will mark them all together. So here we go. Question 6. A cuboid has length 14 inches, width 6 inches, and height 9 inches. What is its total surface area in square inches? So that is going to be 14 times 6, and then 14 times 9, and then the third side, which will be the 6 times 9. So 14 times 6 is 84. 14 times 9 is 126. 6 times 9 is 72. No, it's not. It's 54. Ah, that was the easy one. Right, add these together. Okay, so 54 add 126 is 180. So these equal 264. And then twice that will be 264. Oh, 1 second. 264. Oh, no. 264 times by 2 will equal 528. Okay, and that is square inches. Okay, actually, I am going to just mark these in the batches of 5 again, because I feel like it will keep me on the straight and narrow. Okay, so here we go. Let's work these out here. So number 1, we've got 148, excellent, and that's centimeters squared. Number 2, we've got 376, that's good. Number 3, we've got 320 square inches, excellent. And number 4, we've got 592 centimeters squared. Number 6, 5 even, we've got 32. And number 6, we have got 600. Number 6, we've got 528, and that's fine as well. And then let's continue now on with 7 to 10. Okay, so here we go. Right, so find the total surface area of a cuboid with length 16, width 10, and height 6 centimeters. Give your answer in centimeters squared. So we've got 16 times 10, we've got 16 times 6, and we have got 10 times 6. Okay, so this one is 160. This one is 60. And then 16 times 6. Well, 6 times 10 is 60. 6 times 6 is 36. That's 96. Okay, and then we can add these all together. So 220 for these two. 316. So they add to give 316. Okay, and then we can times that by 2. 316 times by 2 equals 632. Okay, and that's the answer, and it's centimetres squared. Okay, it's a bit of a test on my arithmetic here. Question 8, we've got the dimensions of a cuboid are 7, 4 and 2. So that's going to be, we've got the 7 by 4 sides, we've got the 7 by 2 sides, and then we've got the 2 by 4 sides. Okay, so here we go. 7 by 4 is 28, 7 by 2 is 14, 2 by 4 is 8. If we add these together, what we get is 36, 40, 50. So those add up to give us 50, and then 50 times by 2, that's nice and easy. 100 meters squared, because it's asking for the total surface area in square meters. Okay, right. Next one. Here we go. Question 9. It says if a cuboid has length 9 inches, width 5 inches, and height 3 inches, what is its total surface area? Right, so quickly, let's just change that. I can minimize that now. Where are we with these? We're looking at lots of cuboids. Here we go. Oh. And we've just done question 9. There we go. We just need the 5 to be on the same line as the inches. There we go. And that's that sorted. Okay, so let's crack on. So we've got 9 by 5, 9 by 3, and 3 by 5. So we've got here 45 plus 27 plus 15. 45 and 15 makes 60. Add the 27 makes 87. So 87 times 2 equals 160, 174. And this is square inches. Okay, and then question 10. We have got find the total surface area of a cuboid with length 20, width 15, and height 12 centimeters. Okay, give your answer in square centimeters. Okay, so let's sort that out here. So we have got 20 by 15, 20 by 12, and 15 by 12. Okay, 20 by 15 is 300, 20 by 12 is 240, 15 by 12, that's harder. Well, 10 by 12 is 120, 5 by 12 is 60, so that's going to be 180. So here we go, and then we can add these together. So we've got 540, add 6, so 620, 720. So they make 720 for one set of the sides. Then we need the back, so we've got to do 720 times by 2, and that equals 1,440 centimeters squared. Okay, right, let's have a mark. Okay, gone high risk this time, no calculator. Okay, let's see how it works for me. Okay. So, here we go. Right. So, 632. Yep, excellent. 100. Yep, perfect. 174. Excellent. And then 1,440. Wonderful. So there we go. Right. Now in the scenario form. Okay, so here we go. Right. You want to wrap a gift box in decorative paper. The box measures 12 inches long, 8 inches wide and 5 inches tall. How much wrapping paper will you need in square inches? Okay, right, so we need to find the surface area. So we've got the 3 faces, we've got 12 by 8 face, we've got 12 by 5 face, and then we've got the 5 by 8 face. So here we go. 12 by 8 is 96, 12 by 5 is 60, 5 by 8 is 40. Add these together, that equals 196. Remember, we've got faces on the front and back, so we have to double this. So we've got 196 times by 2, and that's going to equal 392 square inches. Okay, next we have question 2, and this says you are painting the walls of a rectangular room. The dimensions of the room are 10 feet, length 10 feet, width 8 feet, height 9 feet. What is the total area in square feet that needs to be painted? So the walls are just the 4 walls. So we're actually, this is making us think about the rectangles that we want. So we want, the height is key here. So the height refers to the height here. So we need the height times the length to get these two, the wall on the front and the back. So that's going to be the 9 times 10 for the front and the back. And then we want the 8 times 9 for the 2 sides. Okay, so 9 times 10 is 90, plus 72 for 8 times 9, and that equals 162. And then, of course, we've got the 2 sets of each wall, so we still need to double that. So we get 162 times by 2, which will be 324 square feet. Okay. Okay, fine. Right, let's look at question 3. So here we go, we've got here a manufacturer. In fact, one second, about that question. Right, I just want to put a bit of extra bump in there, just because I feel like that could be misleading. You're painting the walls of a rectangular room. The dimensions of the room are 10 feet wide. What is the total area in square feet that needs to be painted? You are painting the 4, there you go. You are painting the 4 walls of a rectangular room. I think that clears it up. You are painting the 4 walls of a rectangular room. Yeah. Right, so let's have a go here. Question 3. A manufacturer is designing a cardboard container for shipping vegetables. The container needs to have a surface area. Oh my gosh. The container needs to have a surface area of 500 square inches to maximize production. If the length and width are both 10 inches, what should the height of the container be? Okay, so this is 10 and this is 10. We don't know the height. Okay, so but we need the whole thing to be 500. So let's say we've got we've got 10. So the measurements that we have are 10, 10, and h. Okay, so let's work out this. So we're going to have a 10 by 10, and then so that's these two, and then we're going to have a 10 by h, and then we're going to have another 10 by 10. Or we're going to have we're going to have another 10 by h. Yeah, because let me just change the colour here. Do this in white. So this here is 10 by h. This one is 10 by h. So there's 4 of them, and then this one is the 10 by 10. Okay, so let's look at this here. So we've got 10 by 10 times 10 by 10. Does this? Okay, and so this will equal, well actually, this will equal half of the sides, so this will equal 500. Let me get rid of that. Plus that, plus that, and that's going to equal the 500. So let's work out what this is. We have got 100 here, plus 10h, plus 10h, okay, and that equals 500. No, that doesn't equal 500, that equals 250, sorry. Okay, so this, so what we've got here is 20 times the height, because if we've got 10 times the height and 10 times the height, that does make 20 times the height. Oh, I've run out of space. Okay, so we have got, that's 250. Now, if we think about it like this, 100 plus this bit here equals 250. So therefore, 10 times height plus 10 times height equals 150, which means that 10 times the height will equal 75. Okay, because we've got this twice, don't we? So 10 times the height equals 75. So that means the height will equal 7.5 inches. Okay, right. Let me just... I did not organise myself very well with this at all. But let's just shrink that a little bit. Okay, so the height will equal 7.5 inches. Okay, right. You are installing wallpaper on the walls of a room with a rectangular floor plan, okay? The room is 12 feet long, 9 feet wide and 8 feet tall. Okay, so let's just put these measurements on here. So 12, the height is the key one, 8 here and 9. So what do we do with this? You are installing wallpaper on the walls of a room with a rectangular floor plan. The room is 12 feet long, 9 feet wide and 8 feet tall. What is the total area in square feet that needs to be covered? So it's just the walls, okay? So again, I might actually edit this and add in the 4 walls. You are... I know it just gets rid of any ambiguity. Right, here we go. So we have got 8 by 12 plus 8 by 9, and then we'll times that by 2 because we've got the front and back for each matching one. So 8 times 12 is 96, 8 times 9 is 72, 96 at 72 equals 168, 168 times by 2 is going to be 336, and that is square feet. Okay, great. Right, question 5. A farmer wants to build a rectangular chicken coop with width 6 meters, length 4 meters and height 2 meters. So let's just put that on. So we've got 6, 4, 2. There will be no mesh on the bottom. What is the total surface area in square meters that needs to be enclosed with wire mesh to make it predator proof? Okay, so we need the top once. So the top is a 4 by 6. So we need 4 by 6 plus the ends, which are 2 by 4, and we want 2 of them, and then plus the front and the back, which are 2 by 6, and we want 2 of those as well. Okay, so 4 times 6 is 24, 2 times 4 is 8, times 2 is 16, 2 times 6 is 12, times 2 is 24. So here we go, we've got 16 and 24 make together to make 40, plus the 24 is 64. So this will be 64 meters squared of wire mesh. Oh, yes, you can definitely. Nangzi, sorry about this. You can definitely access these questions. They are all available on the Crack Maths website. So if you go here, one second, let me just, sneak preview. if you go to crackmaths.co.uk, they are all here, and then you can find them in the resources section, and if you go to tutorials, you can scroll down and find them here. So we are on topic 51, and topic 51 is here, how to find the surface area of a cuboid, and that is, that you can find that here, and here are the questions here. So question 1's there, question 2, and these are the scenario ones here. And also, the reason why I'm editing this is because it's going to be a book. So in a couple of weeks, you will be actually able to buy this and have it for you as something that you can work through and have that as something that you want. So I'm just going to put a comment here. Yes. Visit crack. Oh. 1 second. Here we go. Excellent. Thanks so much for joining in. Okay, right. Okay. Okay, so, right, let me keep going anyway. So here we go. Question 6 here. Oh no, I haven't reloaded my screen. I've got all distracted. I was still getting used to whenever anyone interacts on a live. It's like quite novel for me. We've done up to question 5. We're ready to do some marking. Right, so let's get the mark scheme here. And there we go. And I can minimize this. And we can get these first few marked. Red pen. Okay. So, question 1 is 392 square inches. That's perfect. Question 2 is 324 square feet. Question 3 is 7.5 inches. Wonderful. Question 4, yes, excellent. It's all correct. And then question 5 is 64 meters squared. Right, let's continue with question 6. And then we can go from there. So here we go. Right, so question 6. You're constructing a fish tank with a glass front, back and sides. The sides of the tank need to have a surface area of, so that's the sides of, the sides of the tank need to have a surface area of 600 square inches. If the length and the height are both 12 inches, what is the width of the fish tank? So, the sides of the tank, so that is, again, I feel like it's really ambiguous because the base is a side and the top is a side, but I think it just means the sides. So let me put the 4 sides in there, and then I'm going to put this information in first. So the height is 12 and the length is 12. Okay, so we don't know what the width is. Okay, right, and I'm just going to quickly add the word 4 into that question. The 4 sides of the tank. There we go. And then let's come back to this. So what we have here is we have got right. So we've got the front and the back, which is 12 by 12. So we'll have 2 of those. Okay. So 12 times 12 is 144. 144 times 2 is going to be 288. So that's 288 for the front and the back. Then I'm going to do 600 to take away the 288, which will give me 312 square inches. Okay, now that is for the 2 other sides. So if I divide this by 2, that'll give me for one side. So 312 divided by 2 is equal to 156. Yeah. And then I just need to do 156 divided by 12. 156 divided by 12. And that will give me what the width is. Because, so, oh, I've written 152 there. 156 divided by 12. I don't think this is, oh, it is in the 12 times table. It's 13. Equals 13. There we go. Okie dokie. Right, there we go. Question 7. A construction company is building a storage shed with a rectangular floor plan. The shed measures 20 feet long, 10 feet wide and 8 feet tall. So let's just put that on. 8, 20, 10. Okay, what is, all of the wood needs to be treated with oil on both sides. What is the total area in square feet that will need to be oiled? Okay, so let's sort this out. Okay, so let's sort this bit out here. So what we've got here is we've got 8 times 20. Okay, and then I'll do my first method here. 8 times 20, and then we've got 8 times 10, and then we've got plus 20 times 10. So that's going to be 160 plus 80 plus 200. So they will make 240 together, 440. So 3 equals 440. Then if I times that by 2, I get the whole cuboid. Okay, so 440 times 2. So this will give us the surface area, which will be 880. But they're saying that they want to do both sides. So we don't just want the outside surface area, we want the inside surface area. So we're going to assume that's the same. So we're just going to times this by 2 again. So 880 times by 2 is going to be 1,760 square feet. And again, remember, you can use a calculator with these. 75% of the functional skills test is calculator based, so the likelihood is that you will have a calculator. This is about practicing the skill. Okay, question 8. You are recarpeting a rectangular living room. The dimensions of the room are length 14 feet, width 12 feet, and height 9 feet. What is the total area in square feet that needs to be carpeted? You are recarpeting. Well, surely it's just the floor. So they just want us to work out what are the dimensions of the floor. So maybe I need to specify that. You are recarpeting the floor. I think I should put that in. I think you are recarpeting, because no one recarpet. You do sometimes get some people carpet the walls, but I think it's just best to be clear. So you are recarpeting the floor of a rectangular living room. The dimensions of the room are length 14 feet, width 12. Damn it. That needs a width 12 feet and height 9 feet. What is the total area? Yeah, perfect. So height is here. This is 9. The length and the length and the width don't matter. It just matters that we know that they're not the height. So the floor is going to be the 14 times 12. So 14 times 12, and that will be 14 times 12. I gave up on my mental arithmetic roll. 168 square feet. Okay. Right, question 9. A manufacturer is designing a rectangular shipping box for small electronics. The box needs to have a surface area of 320 square inches. If the length and width are both 10 inches, what should the height of the box be? Okay, so this is 10, this is 10, and then we've got the height. Okay, so we know that it's going to, the sides are going to be, let me do this in white again. So we've got 10 times the height for here. We've got 10 times 10 for here. And then we've got 10 times the height for here. Okay, so basically we have got 4 lots of 10 times the height. Okay, and we have got 2 lots of 10 times 10. And that's going to equal 320. Okay. Okay, thanks so much. Right, so we've got here that we're doing all of this. So this is going to be 40 times the h plus 10 times 10, which is 100, 200, 200 equals 320. So that means that 40 times the height will equal 120. Okay, and then to find out what the height is, we just need to do 120 divided by 40, and that will equal 3. So the height has to be 3 inches. Okay, so the height has to be 3 inches. Right, so here we go. Right, there we go. Right, so question 10. Right, here we go. You've got you are building a rectangular planter box for your garden. The box will measure 5 meters long, 0.6 meters wide, and 0.5 meters tall. Okay, let's just sort that out quickly. 0.5 meters tall. Okay. What is the total surface area in square meters that needs to be covered with soil for planting? You are building a rectangular planter box for your garden. The box will measure 5 meters long, 0.6 meters wide, and 0.5 meters tall. What is the total surface area in square meters that needs to be covered with soil for planting? So this is implying the middle, but I don't think it makes sense. So what does this actually mean? So the thing is that this is trying to say, it's trying to imply that you need to line the inside. You need to put soil on the inside, so it's going to be one base and the 4 sides. Okay. The box will. So I think it actually needs to say something maybe more along the lines of lining. Sorry about this. You are building a rectangular plant box for your garden. I think I'm going to say you are lining a rectangular plant box for your garden. The box measures 5 meters long, 0.6 meters wide, and 5 meters tall. Okay. What is the total surface area in square meters that needs to be lined before covered with soil for planting? Planting if soil will fill the entire inside. Right. You are lining a rectangular planter box. You are lining a rectangular planter for your garden. The box measures 5 meters long, 0.6 meters wide, and 0.5 meters tall. What is the total surface area in square meters that needs to be lined before covered with soil? Before covered with soil. what is it? You're aligning a rectangular planter for your garden. The box measures 5 meters long. So what is the total surface area? That needs to be lined Okay, right, here we go. Right, you're aligning a rectangular planter for your garden. You're aligning a planter for your garden. The box measures 5 meters long, 0.6 meters wide, and 0.5 meters tall. What is the total surface area that needs to be lined if you want to protect the sides and the base from contact with soil? Contact from soil when it is filled. Give your answer in square meters. Okay, right, there we go. I think that'll be fine. I'll have another look at that later. Close. Oh, my share's no longer active. Share, stop sharing. Right, where is it? Let's. Right, here we go. Right, done. So here we go. Anyway, so it's the inside of this that we're up to. Right, so here we go. We've got... so let's have a go at this. We've got 5 times... we've got... So it's 5 meters long, 0.6 wide and 0.5 high. So we're going to have 1 5 by 0.6. And then we're going to do... so that's one of those. And then we're going to have 2 of the times the 0.5 by 5, and then we're going to plus 2 of the 0.6 by 0.5s. Okay, so here we go. We're going to have this is going to be 3, this is going to be 5, and this one will be 2 times 0.6 times 0.3. So we've got here 2 times 0.6 times 0.5, and this will equal 0.6. Oh yeah, of course it does. Plus 0.6. Right, so let's get these added together. So we've got 3 add 5 is 8, plus the 0.6 is going to be 8.6. Okay, right, that question took a little bit longer than anticipated. So let's have a look what is going to go on with that. as we mark it. So here we go. Resize that here. Let's get the mark schemes. Okay, so right, question 6 is going to be here, which is we've got a different answer. Find the surface area of a cuboid. So we've got 12.5 here, and I have got 13. They're very close, but not quite the same. So what have we got? How are we going to let's double check this. So you're constructing a fish tank with a glass front, back and sides. The sides of the tank need to have a surface area of 600. If the length and the height are both 12 inches, what would be the width of the tank? Okay, let me just check my answer by working backwards. So if mine is correct, we'd have 12 times 12 for here. We'd have plus this is 13. So this is 12 times 13 there. And this top one's 12 times 13 as well, isn't it? So we've got 12 times 12 plus 12 times 13. 1 second, but this is just the sides, isn't it? So 1 second, we've got a 12 times 12 plus a 12 times 13, and we've got 2 of these, okay? So we've got this, and we're going to have that times 2. We don't care about the top because it's a fish tank, and we're only talking about the sides. Front, back, and sides, okay? And they're saying specifically front, back, and sides. So 12 times 12 is 144. Okay. And then we've got plus 12 times 13, which 12 times 13 is 156. And then we've got that, and we want to times that by 2. So add 144. Equals this, and then times that by 2 equals 600. So 13 is correct if we stop by that now. Okay, so 13 is right. So we can tick that. We just need to change it in the mark scheme. So that is correct there. Let's get this changed in the mark scheme. 12.5 is very close though. I wonder how I got that last time. So 50. Okay, right. So next one, question 7. 170. Yeah, perfect. This one agrees. Let me go back to here so we can all see. Okay, 7 is correct. Here we go. We can see that there. This next one here is 168. Then what we've got down here is we've got 3 inches. And then we've got here 8.6. Okay, right. Question 52. Let's have a look here at number 52. Yeah, and then... Oh, it's a new topic. Excellent. Right, okay. Here we go. Topic 52. It says here, if a map scale says 1 to 500, how long would a distance of 4 centimetres be in real life? Give your answers in metres and centimetres. Okay, so if a map's... Okay, what's going on here? So map scales are like 1 to whatever. So the units are whatever just goes. So if I've got here 1 to 500, okay, and it's a 4 centimetre distance in real life, That's 4. So we've got 4 lots of this. So that'd be 2,000. So that'll be 4 centimeters to 2,000. Okay. So if it's 4 centimeters on the map, in real life it's 2,000 centimeters. So that's 2,000 centimeters. And then 1 meter is 100 centimeters. So 2,000 centimeters is 20 meters. Okay. So there we go. So it's 2,000 centimeters or 20 meters. Right. Question 2. If a map scale says 1 to 2,000, how long would a 3 centimeter distance be in real life? Give your answer in meters and centimeters. So if it's 1 to 2,000, we want 3. Okay, so that would be 6,000. Okay, so that's 6,000 centimeters, which is also 60 meters. Right. Question 3. If a map scale says 1 to 100, how long would a 6 centimeter distance be in real life? Give your answer in meters and centimeters. So 1 to 100 is like this. So that means 6 to 600. Okay, 600 is 600 centimeters because their centimeters is here, and that would be 6 meters. Okay, so these are answers for this one here. Question 4. If a map scale says 1 to 10,000, how long would a 2 centimeter distance be in real life? So 1 to 10,000 is 2 to 20,000. So that's 20,000 centimeters. Okay, or take off the 2 zeros, that's 200 meters. Okay. Question 5. If a map scale, this was much easier than the area stuff. If a map scale says 1 to 800, how long would a 7 centimeter distance be in real life? So if it's 1 to 800, that means it's 7 to, we times this by 7, which is 5,600. So this would be 5,600, oh gosh, what am I doing? This would be 5,600 centimeters, or 56 meters. Okay, there we go. Right, question. Oh, let's get that marked. Check that I'm on the right track. So here we go. Right, here we are. Question, topic 52. Calculate the real thing. Here we go. So, what did we get first? Yeah, 20. Oh no, I've missed out there. C. Okay, right. We best go edit that. Here we go. 20,000 centimeters. There we go. Nice, easy edit there. Okay, so those are both correct. And then these ones here are correct as well. This one here. One second. Okay, oh dear. The internet isn't doing its best. Oh, no, I don't want that. Right. Let's try once more. We'll close this down and turn this off. And then in the meantime, I'll edit that. Okay. Right. Let's keep going. Right. Sorry about this. My Wi-Fi bars are back to top. Okay, the tablet is starting. I'll just use this moment to have a drink. And then right. Reopen. Oh, I've odd page. Right. Go to page. Sorry, what was that? I'm just getting back to the right page. Right, here we go. Share. Send me screen share. Connect. Sorry about that. Phew. Okay, and then here we go. Right, so we've done these. Did I get all of these marked? I did, yes. Right, there we go. So right, next round. So here we go. If a map scale, oh, what's that? Let's make this large. Right, if a map scale says 1,250, how long would a 10 centimetre distance be in real life? Okay, right, so we've got 1, so that's going to be 1 to 2,500. Oh, no. Sorry, if I use that pen, I run out of space. 1 to 2,500, so that would be 10 to 25,000. Okay, so that is 25,000 centimetres. And then that is 250 metres. Okay, next is question 7. And it says, if a map scale says 1 to 50, how long would a 9 centimetre distance be in real life? So 1 to 50 is 9 to 450. So this would be 450 centimetres in real life, which is 4.5 metres. Okay, question 8. If a map scale says 1 to 5,000, how long would a 1.5 centimetre distance be in real life? So here we go, we've got 1 to 500, 5,000, 1.5, well that's just going to be, let me just get the calculator out for that, so it's 5,000 times 1.5. Okay, so there we go, that's 7,500. So that's 7,500 centimetres, or 75 metres. Right, okay, question 9. If a map scale says 1 to 10,000, how long would a 5 centimetre distance be in real life? So 1 to 10,000 times them by 5, so that's 5 to 50,000. Okay, so that's 50,000 centimetres, or 500 metres. Okay, right, question 10. If a map scale says 1 to 250, how long would a 2.5 distance be in real life? So here we go, 1 to 250, and then we've got 2.5. Okay, so we just do 250 times 2.5. So that's 625 centimetres, which is 6.25 metres. Okay, right. Let's get those ones marked, and then we can crack on with the next ones. Okay, so let's get these marked. Dun, 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 dun. Here we go. And then I need the remarkable, but I need it to the side, and then just, Oh. Right, here we go. So, 25,000 centimetres, 250 metres, yep. 450 centimetres, 4.5 metres. 7,500 centimetres, 75 metres. 50,000 centimetres, 500 metres. And 625 centimetres, 6.25 metres. Right, okay, great. Let's go on to the next ones. Okay, so here we go. Scenario. Let's see what's going to go on with this. Okay. You have a scale drawing of a room where 1 centimetre represents 2 metres. Okay, if the length of the table in the drawing is 4 centimetres, what is the actual length of the table in metres? Okay, so 1 cm. Oh, 1 cm. Oh, thank you. No, that's great. 1 second. 6 says. Yeah. Thank you so much. Right, I didn't want to miss that. I'm not. Right, okay. Lovely. Right. So. Right, here we go. And then let's go back to this. Right, so what we've got here is if the length of the table in a drawing is 4 centimetres, so 1 centimetre equals 2 metres. Okay, so we've got 4 centimetres, so that's 4 lots of this, so that's going to be 8 metres. That is a massive table. There we go. Question 2. We've got, in a scale drawing of a city map, 1 inch represents 5 miles. If the distance between 2 landmarks on the map is 3 inches, what is the actual distance between the landmarks in the map? So 1 inch equals 5 miles. Okay, the 2 is 3 inches. So we've got this times 3. So if I times this by 3 as well, this equals 15 miles. Wonderful, right, so there we go, 15 miles for that second one. Question 3, on a scale drawing of a garden, 1 inch represents 10 feet. If the length of a flower bed in the drawing is 6 inches, what is the real length of the flower bed in feet? There we go. Well, 6 lots of that, so that'll be 60 feet. Question 4. In a scale drawing of a floor plan, 1 centimetre represents 50 centimetres. If the width of a room in the drawing is 6 centimetres, what is the true width of the room? So we're talking about 1 cm equals 50 cm. So we've got 6 cm, so that's this times 6. So 50 times 6 is 300 centimetres. There we go. Oh, what is the true room in metres? So 1 second, let me get rid of that. That's not the final answer. So equals 3 metres. There we go. Question 5. You have a scale drawing of a playground where 1 centimetre represents 1 metre. Okay, if the distance between the 2 swings is 5 centimetres, what is the actual distance between the swings in metres? So we have got 1 cm equals 1 m, so 5 cm will equal 5 m. So there we go, 5 metres would be the answer for that one. So let's get these marked. So here we go. Get this up. Right, so let's scroll up. We have got 8 metres. We've got 15 miles. We have got 60 feet. Yeah, this is great. We have got 3 meters, yeah, perfect. And 5 meters. All correct for those 5 there. Let's do these next 6 and see how we get on. Right, question 6. In a scale drawing of a world map, 1 inch represents 1,000 miles. If the distance between 2 countries on the map is 2 inches, what is the real distance between the countries in miles? So we have 1 inch equals 1,000 miles. Okay, so then 2 inches would equal 2,000 miles. Okay. Question 7. On a scale drawing of a street, 1 inch represents 20 yards. If the length of a building in the drawing is 8 inches, what is the actual length of the building in yards? Okay, so 1 inch equals 20 yards. 8 inches is this times 8, which would be 160 yards. Okay, right, question 8. In a scale drawing of a hiking trail, 1 centimetre represents 500 metres. If the trail in the drawing is 3 centimetres, what is the true length of the trail in kilometres? Okay, right. So 1 centimetre equals 500 metres. Okay, 3 centimetres will equal 1,500 metres because I've times that by 3. Now, 1 kilometre equals 1,000 metres. This is something that we need to know. And so, I almost drew it there anyway. 1.5 kilometres is 1,500 metres. So the answer is 1.5 kilometres. Okay, right. Question 9. You have a drawing of a classroom where 1 inch represents 2 feet. If the width of a desk in the drawing is 2.5 inches, what is the actual width of the desk in feet? Okay, so 1 inch equals 2 feet. So we want 2.5 inches. So we have to times this by 2.5. 2 times 2.5 is 5 feet. Okay. Right, question 10. On a scale drawing of a city skyline, 1 inch represents 1,000 feet. Oh, that's a lot. If the height of a building in the drawing is 4 inches, what would be the real height of the building in feet? Interesting. I wonder if... 1 second. Let's do this first. Equals 1,000 feet. So 4 inches would be 4,000 feet. Are there any buildings in real life that are 4,000 feet tall? Because that seems pretty high. I wonder. Right, let's... but I'll wonder for later. Right, so here we go. Let's move this here. Okay, so question 6. 2,000 miles, 160 yards, 1.5 kilometres, 5 feet, 4,000 feet. Okay, great. Topic 53. 1 second, sorry, I just need to check something. Okay, no worries. Right, let's get going with topic 53. So, make a scale diagram from actual... Oh really? And is that the highest building? Because that is... So 4,000 feet is still like twice, like almost just over twice that. So... No, it's not close to it. It's just over 100,000 more. So, no, there won't be any maps. Oh well. I don't think it matters. It could be a skyline from a different planet. Right. if a measurement is originally 400 meters, what would be its length on a scale drawing if the scale was this? Okay, so we're working differently this time. So we've got 1. We know that 1 to 200 becomes something to 400. Okay, well that's nice and easy. So we can see we've got 2 lots of that. So we'd have to do 2 lots of this. So that's going to be 2 to 400. Okay, so 2 to 400 is, it will be 2 meters. Okay, so if it's 1 meter to 200 meters, or 1 of something to 200 meters, okay. So here we go. If we've got, if we've got here 2 meters for the first one. Right, question 2. Reduce a measurement of 750 meters using a scale of 1 to 200. What is the reduced length? Okay, so 1 to 200 again. So it's got to be 750. So we need to find out how many lots of 200 make up 750. So we just do 750 divided by 200 to find out what this is. So let's get the calculator out for that. 750 divided by 200 equals 3.75. Okay, so it'll be 3.75, and that is meters. I'll just use that one as the answer there. Question 3. If an object originally 800 meters long if an object is originally 800 meters long, how long would it be on a scale drawing with a scale of 1 to 200? Okay, so 1 to 200, it becomes 800. Okay, well I can see that that is times 4. So this would be times 4, so it would be 4 meters in real life. Okay, right, question 4. Reduce a measurement of 250 meters using a scale of 1 to 200. What is the reduced length? Give your answer in meters. Okay, so we've got 1 to 200, but we want to get up to 250. Okay, so again we need to do 250 divided by 200 to find out how many lots of 200 make up 250. So 250 divided by 200 means we're timesing this by 1.25, which means it's 1.25 here, which means it's 1.25 meters. Okay, right. Question 5. If a distance measures 1,200, what would its length be on a scale drawing with a scale of 1 to 200? Okay, so here we go. I seem to really like this 1 to 200 scale when I did this. Maybe I should go and change it a little bit. I don't think it matters too much. Here we go, so that's 6 lots of this. So that would be 6 lots of this. So the answer would be 6 meters. Okay, right, let's get these ones marked. Okay, here we go. And then let's get out the answer scheme. Right. Okay, so question 1. This is 53, isn't it? So it's this one here. 2 meters, 3.75 meters, 4 meters, 1.25 meters, 6 meters. Right. Question 6. Right. Question 6. Reduce a measurement of 550 meters using a scale of 1 to 200. Okay. It's 1 to 200 again. I don't... maybe I'll go back and change this. Okay. So here we go. Let's work out what this is. So 550 divided by 200 and that is times 2.75. So this would be 2.75 meters. If an object is originally 1,500 meters wide, how wide would it be on a scale drawing of 1 to 200? Give your answer in meters. So we've got 1 to 200. We want to get to 1,500. So we'll do 1,500 divided by 200 is 7.5. So we've got 7.5 lots of the scale. So this is 7.5. And so that's 7.5 meters. Okay. Question 8. We've got reduce a measurement of 300 meters using a scale of 1 to 200. What is the reduced length? Give your answer in meters. Okay, so we have got 1 to 200 again, and we need to get up to 300. Well, I know that this is times 1.5, so this would be 1.5 meters. Okay, question 9. We have got, if a road is initially 900 meters long, how long would it be on a scale drawing with a scale of 1 to 200? Give your answer in meters. Okay, so 1 to 200, we need to get up to 900. I know that that is times 4.5, so this would be 4.5 meters. Okay, I'll actually write it here, 4.5 meters. And actually, I don't like that I put that there. I'm just going to put 4.5. Okay, right. Question 10. Reduce a measurement of 1,800 meters using a scale of 1 to 200. What is the reduced length? Give your answer in meters. Okay, so 1 to 200 is something to 1,800. I know that that is times 9, so it'll be 9 times that. Okay, so it's going to be 9 meters. Okay, right. Let's get these marked. Right, so right, we've got 2.75, 7.5, 1.5, 4.5, yeah, and 9. Wonderful. Okay, right, on to the scenario questions for these ones. This might be our last round of questions, because I think I'm gonna run out of time. Question 1 is the height of a building. Oh no, let's make that large. The height of a building is 10 meters. What would the height of the model on a scale drawing using... What would the height of the model be on a scale drawing using a scale of 1... Oh, let's give your answer in centimeters this time. The height of a building is 10 meters. What would the height of the model... What would the height of the model be on a scale... Oh, that's confusing, because it's not a model. Right. This doesn't read right. Is it a scale model or is it a scale building? Right. The height of a building is 10 meters. Okay, that's fine. Perfectly acceptable. What would the height of the building be on a scale drawing? That's what it's meant to be. What would the height of the building be? Where are we? Wow, that was lucky. No, this is 52. What's that? 53. 53 scenario we want. Okay, what would the height of the building be on a scale model? On a scale drawing. The height of a building is 10 meters. What would the height of the building be on a scale drawing using a scale of 1 to 500? Give your answer in centimeters. No worries, thank you so much. You too, have a lovely weekend as well. Thanks so much for joining. And thank you for the help as well. Great tips. Right, so. Right. Okay, right. So, right, let me just... Back to here, let's answer the question. What would the height of the building be on a scale drawing using a scale of 1 to 500? So, let's convert the 10 metres into centimetres. So 10 metres equals, well, let's go here. 1 metre equals that. So it will be. So the height of the building would be 2 centimetres. Okay. If the length of a car is 4 metres, the length of a car is 4 metres. If you were to draw a scale model of the car using a scale of 1 to 200, what would the length of the model be? Give your answer in centimetres. Okay, so 4 metres equals 400 centimetres. Okay, so the scale is 1 to 200. So we need this to be 400. So that's just 2 lots of the scale. So it would be 2 centimetres. Okay. Question 3. The width of a garden is 20 metres. If you were to make a scale drawing of the garden using a scale of 1 to 100, what would the width of the model be? Give your answer in centimetres. So, if we've got here 20 metres, well, 1 metre, as we said, is 100 centimetres. So 20 metres will be this times 20, which will be 2,000 centimetres. The scale is 1 to 100. We need to get to 2,000. So we've times... Oh, right, well, we've times this by 20. We kind of did it there. So it'll be here, so 20. So the width of the drawing would be 20 centimetres. Okay. Question 4. The diameter of a circle is 8 metres. What would the diameter of a circle in a scale drawing be using a scale of 1 to 50? So 8 metres equals 800 centimetres. If the scale is 1 to 50, we need to get up to 800. 50 times what gives us 800? Let's just find this out by doing 800 divided by 50. So that's 16. So that would be 16. So it would be 16 centimetres. Okay, right. Question 5. The distance between 2 cities is 150 kilometres. If you were to create a scale map using a scale, if you were to create a scale map, I think we can say if you were to create a map, because I think the map implies the scale, doesn't it? If you were to create a map using a scale, there we go. If you were to create a map using a scale of 1 to 500, what would be the distance between the 2 cities in the map? Give your answer in metres. So we have got right, 150 kilometres. So 1 km equals 1,000 metres. So 150 km equals 150,000 metres. The scale is 1 to 500. So we need to get to 150,000. Okay, so I don't know that. Let's just use the calculator. 150,000 divided by 500. 300. Ooh. So this is a big map. I feel like they might have got their scale a little bit wrong on the map for this one. But we're saying 300 metres. Okay, so anyway, let's have a look and see if these answers are correct. Okay, and then we can go over here. And then right, so this looks promising. I remember there being a lot of 2s. Yeah, so 2 centimeters, 2 centimeters, 20 centimeters, 16 centimeters, and 300 meters. Wonderful. Okay, right, last round for this round. Okay, we'll stop after these. Okay. 1 second, I just need to check something. Right, so here we go. We have got here the length of a swimming pool. So I'm just going to actually. The length of a swimming pool is 25 meters. What would be the length of the model on a scale drawing? I made this mistake before with the writing. I think I was thinking about scale models, scale drawings, and it all went wrong. What would be the length of the pool on a scale drawing? Maybe be specific. What would be the length of the swimming pool on the scale drawing using the scale of 1 to 250? Here we go. What would be the length of the swimming pool? On a scale drawing using a length like this. Okay, so 1 second, so 1 meter equals 100 centimeters. Okay, so 25 meters is 2,500 centimeters. So we've got 1 to 250 here. We need to get to 2,500. Okay, so actually we can see here that this is just times 10. So that would be there. So it would be 10 centimeters. Right. Question 7. If the width of a room is 6 meters, the width of a room is 6 meters. If you were to draw a scale diagram of the room using a scale of 1, I think I don't need the word scale there. If you were to draw a diagram of the room using a scale, here we go. If you were to draw a diagram of the room using a scale of 1 to 1,000, what would be the width of the model? Oh, it's a diagram. Right, 1 second. What would be the width of the diagram? Here we go. Diagram. Give your answer in millimeters. Okay, right, so 6 meters equals 600 centimeters. Now every centimeter is 10 millimeters, so this also equals 6,000 millimeters. And this makes sense with the scale. So the scale is 1 to 1,000. We're going up to 6,000. So that's 6 lots of that. So this would be 6. So the answer would be 6 millimeters. That would be a very small diagram of the room. Right. Question 8. The altitude of a mountain is 5,000 meters. What would be the altitude of the model on a scale? Okay, right, fine. Again, I really think I wanted to shoehorn in the word model somewhere. What would be the altitude of the mountain on a scale drawing using a scale of 1, I think I should, to 10,000? Does it need it? Give your answer in centimeters. Okay, right, so here we go. What bit? Mountain. I know here. It's not a 3D drawings aren't 3D. 1 second. This is where I wanted to use the word model. There we go. Oh no, wrong one. Wrong one again. Here we go. Altitude of a scale. There we go. Right. The altitude of a mountain is 5,000 meters. What would be the altitude of the mountain on a scale model using a scale of 1 to 10,000? Give your answer here. So 5,000 meters equals 500,000 cm. So we're going 1 to 10,000. Okay, and we want to get to 500,000. Okay, so that's 50 times that. So this would be 50. So the answer would be 50 centimeters. Okay, right, question 9. We have the distance between two landmarks is 2 kilometers. If you were to make a scale drawing using a scale of 1 to 5,000, what would be the distance between the two landmarks on that drawing? Give your answer in centimeters. The distance between two landmarks is 2 kilometers. If you were to make a scale drawing using a scale of 1 to 5,000, what would be the distance between the two landmarks on the drawing? Give your answer in centimeters. Oh wow, so 2 kilometers equals 2,000 meters. 2,000 meters equals 2,000 with an extra 2 zeros centimeters, which is 200,000 centimeters. So if it's 1 to 5,000, it's something to 200,000. Okay, and I'm just going to here, just because it's easier, just do 200,000 divided by 5,000, and that's times 40. So it would be 40 centimeters. Okay, question 10. The length of a football field is 100 meters. What would be the length on the model on a scale drawing? Okay, right, again. The length of the football field on a scale drawing. Here we go. What would be the length of the... Okay. What would be the length of the football field on a scale drawing using a scale of 1 to 1,000? Give your answer in centimeters. Okay, so let's see what's going to happen with that. So 100 meters equals 10,000 centimeters. I just times it by 100. Okay, so 1 to 1,000. And then we need to get it to go to 10,000. So that's times 10. So that means 10. So it'd be 10 centimeters. Okay, right, let's do that. I think we can finish off just before 4 if we're lucky, because that's what I need to do. Okay, let's quickly get this. Okay, and then we can mark these. Come on, be right, be right, be right. 10, excellent. 6 millimeters, perfect. 50 centimeters, wonderful. 40 centimeters, brilliant. And 10 centimeters, hurrah! Right, well, thank you very much for joining me today on this. It's really appreciated, really appreciate for all your feedback and effort. And again, that is up to 54. We'll be starting on 54 with the next topic. So that's fantastic. So we've got very few left to go. And so then the book shall be out very shortly. And you can all enjoy it over the summer. Right, okay, I will see you soon. So long, bye.